Hi everyone, so today I'm going to be going over the magnetic field of a bar magnet. This was our lab 2 for physics 2212. And so in this lab, the purpose of the lab was to measure a magnetic field that is distance dependent using a bar magnet. So in my case, the system was the bar magnet and the surroundings was my phone and the earth. So the data that I gathered will be also compared to the predicted distance found through the PHYS law, both on the axis and off-axis magnetic fields using a Glowscript code that I made. And so a little overview of my results. I got my n to equal negative 3.0133, and the magnet's magnetic dipole moment at 45 degrees ended up being 4.375 amp meter squared. And so these were the main three principles that I utilized during the entire lab. So I used PHYS law, which relates the magnetic field at a point to a small element of the current, magnetic field of a dipole, which basically states that electrons are circulating around nuclei while spinning, and that creates a dipole that creates a magnetic field strength. And the distance dependence formula is the magnitude of a magnetic field, and that's inversely related to distance, as shown here. And so this is how I set up the experiment. So I used the magnometer app on my phone to make it perpendicular to the Earth's magnetic field. And so I located the magnometer on my phone, and then I measured the distance between the magnometer and the bar magnet for on and off axis cases. And so for the on axis cases, this ended up being my data. And so on the left is the distance measurements for different magnetic field strengths, and then on the right is a linearized plot of the averages. And I can't really zoom in here, but I can show how this linearized data relates to my values n and k. And so since I was able to have this distance dependency formula as a linearized formula, I was able to use this n and k to figure out my dipole moment mu, and that ended up being 4.375 amp meters squared. And so now moving on to the on-axis, off-axis experimental setup. This diagram is how I set it up in person, and my data is shown as right here for a distance that was around 0.1976 repeating meters. And so now that I have the data in person, I ended up making a Glowscript where my code tried to find the magnitude of B. And so I ended up changing the magnitude of mu right here. It's kind of hard to see, but I changed it to my value, which I found to be 4.375 in the previous section. And then I call it a sideways distance, but this is the same thing as deep perpendicular, and so I changed that to my value right here, and this is what my diagram ended up looking like. And if you look at the values, it was pretty similar to what I ended up getting. And so why were my answers different from the predicted model? So some of the assumptions I made were that I assumed that the magnetic field weakens with increasing distance, and I also assumed that the bar magnet behaves like a magnetic dipole. There were probably also some errors from my phone's position, as I tried to measure as precisely as possible, but it might have not been the most precise. And it could have also been affected by nearby electronic or magnetic objects that interfered with the magnometer's readings. And moving on to the true or false questions, so basically I had to indicate which one were true statements and which one were false statements. So according to the data, it was shown that when the magnometer is far away from the magnet, it measures near zero magnetic field in the x direction, and as the magnometer moves closer to the magnet, the measured x component of the magnetic field ended up increasing. And these are basically kind of the opposite statements of that, and therefore they're false. And so to answer some of the what-if questions, so for the first one, the Earth's magnetic field would influence the bar's field and alter the x component results, and that's how the x results would have changed. And so if I had two identical magnets and redid the experiment, they would be different in the sense that the magnetic dipole moment would be stronger, and so the field's magnitude would roughly double, but like be in the same direction. Thank you so much.